Hey folks, welcome to the Neo4j stream. Today we are continuing on with our Gatsby travel guide using GraphQL and Neo4j. Today we're going to be adding maps using Mapbox GLJS to our Gatsby application. In two places, which we'll talk about in a second. Before we get started, though, something I want to mention. So next week on the stream, at this same time, next Thursday, we're going to start something different. We're going to start a full stack GraphQL book club series. So if you don't know, I've been working on a book on full stack GraphQL for a while now, and there's a free excerpt out that available now, which you can download here. I'll drop the link in the chat. And this is an excerpt of 3 chapters from the full book, sponsored by Neo4j, with a focus on the back end. So what we'll do starting next week, I thought it would be fun to have sort of a book club on the stream where we work through the exercises from each chapter. If you want to see the table of contents, you can see the full one at grandstack.io/book. That has the full table of contents to give you an idea of what's in there. But this excerpt anyway is what we'll start with. It has chapters 1, 3, and 4. So sort of an overview of GrandStack, how the pieces fit together, a little bit about Neo4j and the GraphQL integrations for Neo4j, and then how we implement GraphQL backends. So anyway, so if you want to download that, this is the link to the free excerpt download of 3 chapters, and we'll start next week on the stream, sort of working through the exercises from chapter 1. So if that sounds interesting, definitely give that a download and tune in next week for working through chapter 1 together. Uday says, good morning from Australia. Good morning to the future in Australia. Cool. So that's for next time. What are we going to do today? Well, here is the travel guide Gatsby project we've been working on. This is the GitHub page for it. I'll drop that link in the chat. And I have everything running here connected to my sandbox instance. So I've got the GraphQL API running here. I should say the Neo4j GraphQL API running here. That's talking to my Neo4j sandbox instance with OpenStreetMap data. And then I've started my Gatsby project, which is running on localhost 8000. Here's our travel guide. So this is a statically rendered site with Gatsby. So it's pulled in content from our Neo4j database, points of interest from Central Park. We have some data here about each point of interest that we're pulling in from OpenStreetMap through Neo4j. We've stitched in images for each point of interest using the Mapillary API, and where available, we've pulled in data from Wikipedia for each point of interest. So that's what we have so far. What I want to do today is now add some maps in a couple of different places in our Gatsby application. The first place I want to add a map is here on the index page at the top here, because I want to show sort of markers for every point of interest that we have, right? Like these are all points of interest in Central Park. I want to show those on a map so you can have an idea of where they are. And then I want the map to be interactive, so I want to be able to click on a marker, I want to know what point of interest it is, or maybe like what category it is. We have types for all of these, which I guess we're not actually showing here, are we? Let's see. We have a name and a type anyway. And then I want to link to the actual detail page for the point of interest from the map view. So that's one place we want to add a map, just like an overview. But then also, if you remember 2 sessions ago, we spent a bunch of time showing how to do pathfinding graph algorithms to do efficient routing between points of interest. And so what I want to do today is take advantage of that. So add a second map on each detail page for each point of interest that shows us on the map where the point of interest is, but also will allow us to select any other point of interest and then draw us on the map the most efficient route that we've calculated using, in this case, the A-star pathfinding graph algorithm to get us to our next point of interest for our tour through Central Park. So that's the plan for today. We're going to use Mapbox to do that. We'll need to take a look at some React wrappers around the Mapbox GLJS library. And then we'll do something new that we haven't done with Gatsby yet, which is query our Neo4j GraphQL API sort of dynamically, so outside of the build process. So far, we've used that GraphQL API that has data from Neo4j and OpenStreetMap. We've used that during the Gatsby build process to build these pages, but that's just static content, right? So we've built these pages statically so that when we actually load these pages, we're loading static HTML. We're not actually hitting the GraphQL API. But because we want these routes to be dynamic, one, we don't know what the user is going to select. So we want to calculate those routes as the user is selecting those routes, but also, maybe we want to be able to factor in things like traffic conditions or if a sidewalk is under construction, something like that. So we want to be able to update our OpenStreetMap database on the back end and have routes change to reflect that. So we don't want to build all of these ahead of time statically. So anyway, that's something new. So we'll have to figure out how we can use Apollo Client within Gatsby to query our GraphQL API outside of that build process. Cool, so that should be fun. Okay, so I linked the code to get started. I guess the other thing, if you're following along, that you'll need is the specific link to the specific sandbox. So this is a link to the specific OpenStreetMap sandbox that you'll need that has all of the data from OpenStreetMap on our points of interest that we use to build our routing graph on top of. Renato says, hello all. Hi, Renato. Where are you joining from today? Okay, cool. So let's get started. So first off, we want to add a map right here with markers for all of our points of interest. How are we going to do that? Well, we said we're going to use Mapbox GLJS. So let's take a look at that. So Mapbox GLJS is a really nice JavaScript library for adding interactive maps into your application. The GL comes in that it uses WebGL to render maps from vector tiles, so we get nicely performant maps there. It also hooks into Mapbox styling, so we can style maps using I think it's called Mapbox Studio, and hook into lots of different Mapbox APIs, which we won't play around with too much in this case. We will not use any Mapbox specific features really. There's another library called Leaflet, which I think Mapbox.js is based on. There's some relationship there that has very similar APIs. So we could use Leaflet as well, but I like this library. There's nice React wrappers for it. So in addition to rendering the map and the tiles, what are we going to need? Well, if we look under markers and controls, we'll need to be able to display markers on the map, so that's good. And then we're also going to work with pop-ups. So if we take a look at, there's some examples here. Yeah, displaying a pop-up on click. So this is kind of what we want, is we want to add a marker for each of our points of interest. And when we click on it, we want to show the name, the type of the point of interest. Ooh, maybe we could render our mapper photo in here too. Maybe that'd be a good one. But then the important thing is we want to link to the detail page for the point of interest so we can click into it. Uday asks, would there be any date time input in the central perk data? I don't think so. I don't think we have any date time data that we're working with here. I can think of a few features we might want to add that would factor date time stuff into account. Maybe something like showing the walking time or the travel time between points of interest. We know the distance of the route, so that might be something we could calculate if we make some assumptions about how long it takes to walk a certain distance. We could also maybe keep track of like a list of when we visited certain points of interest. That might be something to keep track of, like a travel journal or something like that. So I could see maybe we get to some of those things, but not today anyway. I don't think we'll touch on. Okay, so that's Mapbox, and you can see from the examples here how the Mapbox API works. But we're using Gatsby, which uses React, so we could sort of build our own wrapper around this, create our own sort of Mapbox React components. But there are a few things we'd have to think about, such as managing state for the map. React likes to control state, so we'd kind of have to use a ref to just sort of pass that through. I did this for another example. I think this is still online. What was this called? Let's see if we can find it. I think it was business reviews. Business search, not that. Date time, no. Oh, it was routing. We do that in the routing app. There's a simpler one though. Business search, routing app. Well, in the Willow one, if you remember the Willow real estate project that we did on the live stream, the previous project, we used a React wrapper around Mapbox, which is what we will do today. Oh yeah, space-time reviews. That's what it was called, this one. So in this project, So the idea here is we had some, oh, that's too big. We had some business reviews data from Yelp. And what we wanted to do is be able to filter in this distance radius, move this marker around, find businesses within that radius, also filter by date range, and then do some dynamic calculation on the distribution of, I think we're looking at the stars of businesses, or the stars of the reviews, and, oh yeah, the category distribution is what it was. But anyway, so in this case, this was a React application, and we created a map component here that wrapped Mapbox GL JS, which you can see here. So it was a bit awkward though, because we had to think of keeping track of the state for the map outside of React. Wouldn't it be nice if we could sort of use React state to also work with our map components? And so for that sort of usage pattern, there are a few React wrappers around Mapbox. We used one of them in the Willow project. So if you remember that, we will use the same one again, which is this one, React Map GL from Urbica, which is like a design studio. So they make really cool interactive data visualizations, and they've built this React wrapper around Mapbox GL that exposes lots of different controls. The only two that we need right now, though, are marker and pop-up. So those are available as React components, which is exactly what we need. There's a similar one to this that comes from Uber's Visualization Studio that I've used also, that I think now has similar features at this point to the Urbica design version. But anyway, we'll use this one today. I like this one. We've used it before. So let's take a look at the docs to see how we can add this. So first off, installation. Let's go ahead and install it. So npm install save Urbica React Map GL and Mapbox GL. And while that's installing, let's look at the docs here. So here's an example for a static map or an interactive map. I'm going to start with the interactive. Oh, we get an error. API access token is required. So we need a token. Let's go to Mapbox and get that. You can get a token for free from Mapbox up to so many renders of the map are free, and if you hit a certain threshold, then you have to start paying for their service. But we can use a free token. So if you have a Mapbox account, you can just sign in for free. You can see I have lots of free map views to go, and not even approaching the paid version. I'm just going to use the same token that I used for Willow. I think that's fine. So we'll copy that. I'm going to save that somewhere off screen for now. We'll come back to that. What I want to do it now, though, is paste this in the docs. So we need to provide our own key in the docs for it to render. That's fine. Okay, so here's an example. So we can see what's going on here. We're using the use state React hook for managing state in our React component. And then we create a viewport state variable. So that's latitude, longitude, and zoom. So this is the center of the map. Let me zoom in a little bit, speaking of zoom. Center of the map and then the zoom level of the map are stored in the state variable. And then on viewport change is the set viewport function, which is our React state function for updating the viewport. So you can see we're keeping track of the state of the map in the React component so that as we maneuver around, that's changing the viewport latitude and longitude of our React component by calling this set viewport function. Okay, I think that's enough to stick a map in our Gatsby application. So let's go to, what are we looking for here? We're looking for the index page. So just looking at the documentation over here, we'll need the use state hook. And then we'll need to import mapgl from Urbica React mapgl. And we'll need this CSS so that it looks pretty. Mapbox gl.css. Okay, and then in our component, we need to create a viewport state variable. And we'll set the initial latitude. This is what, San Francisco? Latitude, longitude, and the zoom level. We don't want San Francisco though. Central Park, latitude and longitude. There we go. So let's center this on Central Park. So latitude 407812, longitude 739665 west, and if it's west, it's negative 73. Okay. And then where should we put it? Well, we have the title and the bio component, and then we start iterating through each one of these. So maybe let's put it just before this list, right before we start to list all of the posts. So that would be right here. Let's get the docs back. So mapgl. I'll just do a self-closing there. And then for the props, style will be simple. We'll just let it take up 100% width and height. And map style. So this is where we could make this our own custom style using Mapbox Studio. Let's just use this default style for now, light V9. Okay, our access token let's come back to this one. We don't want to just paste in our token there and have that checked into our code. We want to put that in as an environment variable. So our latitude, this is going to be viewport.latitude. So as we're moving the map around, we want our viewport state variable in our React component to update. So we're going to bind that to the prop latitude here. Same for longitude. Viewport.longitude, and I spelled longitude wrong. Longitude, not tide. Zoom, same thing. Bind that to viewport.zoom. And on viewport change, we want to call set viewport, which is our function that's going to update our viewport state variable. Okay, so the only thing we're missing here is the access token. So we said we want to set this as an environment variable. How do we do that in Gatsby? Let's take a look. Gatsby environment variables. So there are a couple of ways to think about and use environment variables in Gatsby. One is build time variables, right? So Gatsby runs a Node.js process at build time, and we may use some variables there, such as, I don't know, connecting to some other GraphQL API, stitching it in like what we do with our Neo4j GraphQL API. And then there are the client-side environment variables, like here for our access token, which aren't really defined as operating system environment variables, right? These are just sort of substituted in the static HTML. So what we're going to do is, according to this, if we create a .env.development and .env.production, then Gatsby build process will substitute in environment variables that we specify prefixed with Gatsby. So in this sort of namespace, Gatsby underscore. So this will be right here, not processing instructions, process.env.gatsby Mapbox key, let's call it. And then we need to create a new file up here called .env.development, which we already did, and paste in our Gatsby Mapbox key. Cool. So let's see what that looks like. Right, so let's do a Gatsby develop to build our site again. And this will take a few seconds because we need to check the mapillary API for each point of interest. I think that's at this point, the slowest part of our build process. Did anyone attend Node's online conference this week? I know Uday did. Gave a great talk about security using GraphQL, AppSec, which was really cool. Was anyone else at Nodes? What did you think? Any feedback? Any thoughts? If you don't know what I'm talking about, that would be the Nodes 2020 online conference, which was a couple days ago. And one thing that's neat is all of the videos and slides are up now. So if you just want to watch the recordings, check those out. I'll drop a link in the chat. There was a keynote from Emil and lots of talks about graph data science, some talks about GraphQL, visualization, a look at building applications with Neo4j. So lots of good stuff there. Hopefully that was enjoyable if you made it. Renato says he was there. Great. Okay, cool. Our site has built. Uday says the graph native machine learning announcement was great. Yeah, there's a lot of interesting stuff going on in graph data science. That's a really interesting area. I think the graph embeddings stuff was really interesting, which was talked about. Yeah, so definitely check out those recordings if you missed it. Okay, our site has built, but I don't see a map. Let's see what happened there. Let's open up our console. What happened? I see a warning. But I don't see our map. Why not? Let's inspect. So there is a map here. But why don't we see it? It doesn't have any height. So let's just specify a height here in the style. 600 px. There we go. Okay, there's a map. Here's Central Park. We could probably zoom in a bit more initially, maybe like a 13. Since everything, there we go. So all of our points of interest are going to be here in Central Park. Cool, and as we move it around, you can zoom in. Cool, so now what we want to do is add some markers for our points of interest. So let's look at the docs and see how we do that. We want marker. And a marker is just a child component of the map. So let's import marker and create a new marker. Oops. As a child component. It needs to have some content in the marker, which we'll worry about in a second. Okay, and it needs latitude and longitude. And then this is a draggable marker. Let's add in our key here so we can see what this looks like right here. All right, so here's a big giant marker, and this is draggable, but we don't want it to be draggable. Our points of interest are not going to move, so let's not worry about that. And let's just use viewport latitude and viewport longitude. So we'll just put a marker in the center of the map. And there it is. So notice that our marker, we don't have like an icon or something by default. It can be whatever we want to stick in there, including, so I think when we did this previously on the real estate application, we had a div that we added some CSS styles to make it like a blue dot or something. But we can also use SVG. So I cheated and found SVG of a small like pin marker. So I'm just gonna copy paste that in. And now, there it is. So it's a little tiny red pin. Okay, so that's fine, but we don't want a marker just in the center of the map. We want it for all of our points of interest. How are we going to do that? Well, if we look at what's going on this page, if we remember what this page is, so this is the index page, and there's a GraphQL query here that is fetching all of the posts. So we have what we need already. And we can see here where we're mapping over this post variable that has the detailed information for the post, including latitude, longitude, name, and type. So what we want to do is render a marker for each post. So we'll say posts.map, and then we'll iterate over each point of interest. We'll also get the index. We'll see why that is needed in a second. And then for each point of interest, we're going to return a marker component, and we'll set the key prop to be the index in the post array. So React wants a unique ID anytime we create an array of these components. And the longitude is going to be poi.location.longitude, and latitude is poi.location.latitude. That's the marker, and then in each marker we have, copy again, our SVG. And let's delete our previous marker that we were just putting in the middle of the map, since we don't really need that. And now we've got markers for all of our points of interest. Cool. So that's a start. Next thing we need is when we click on one of these, we want to show a pop-up, and that pop-up should have detailed information about the point of interest and also link us to the detail page for each point of interest. So if we take a look at the docs here for pop-up, and let me find my Mapbox key again so we can see what this looks like in the docs here. Okay, a pop-up with some content into it. Yep, that's what we want. So how do we sort of bind a pop-up to a marker? Do we need to create a pop-up for, oops, here's what we want. Do we need to create a pop-up for every single marker, sort of like as we do this iteration, and then show and hide it when we click on the marker? Well, we don't need to do that. We only need to create one pop-up component because we're only going to be showing one pop-up at a time, so you can only select one marker, one point of interest at a time. So we're only going to need one pop-up. How are we then going to figure out what to display in the pop-up? So what we'll do is we will use another state variable. Let's go ahead and create that. Let's call this show pop-up and set show pop-up. And initially set this to false. So we're going to have this state variable, and this show pop-up state variable is going to keep track of if we should show a pop-up or not. And it'll also need to keep track of the information that we need to show in the pop-up, but let's worry about that in a second. So right here, after we've rendered all of our posts, we'll say if show pop-up is true, then render the pop-up. Let's look at our docs for the pop-up here. Did we import it? Up here, no. Import pop-up, marker, comma, pop-up. Okay, and our pop-up needs some location, right? So it needs a latitude. For now, let's just use viewport.latitude, so it'll just show up in the middle. And a longitude, viewport.longitude. Close on click. So do we want the pop to close when we click it? No, I don't think so. Not sure what the default is there. What else? We can also set a tip size. We look in all the props that we pass. I think there's a tip size. Let's set that to 5. We'll anchor it at the top. And well, let's set this to true. So if we save this right now, are we going to see a pop-up? I think that we will not see a pop-up. Nothing happens when we click a marker. Why don't we see a pop-up? Well, because we set show pop-up initially to false. And here we're checking, is show pop truthy? If it is, then render the pop-up. If we change this now to true, so set the initial show pop-up value to true, then yeah, here's our pop-up. And we didn't give any content to our pop-up, so it's kind of hard to see. Let's add something in there. We can put a div in there that says, I don't know, hello there. Okay, there's our pop-up. We can close it by clicking that X, but then we don't get it back. So, okay, we want to show the pop-up. So what we're going to do is on our marker, we are going to add a click handler. So let's add that. I think we can add that here. So on click, we're going to call set, what did we call it? Set show pop-up. Set that to true. Let me format. There we go. It's a bit more readable. So when we click on our marker, we're going to call this set show pop-up function that is going to update our show pop-up state variable. And let's change now the initial value to false. So initially don't show the pop-up, but when I click one of these markers, then you should show it. Okay, and what's going on there? So I'm clicking, but I'm not seeing it. Well, that's because our show pop-up and the visibility of the pop-up got out of sync. So we need to explicitly, for our pop-up, we need to explicitly call, if we look at the docs here, the onClose function. So onClose, when our pop-up is closed, we need to call set show pop-up and set that equal to null or false. So now I click a marker. Let's refresh. I click a marker, it shows me the pop-up. That is setting the show pop-up state variable to true. I close it. That now the onClose handler calls set show pop-up, sets it as null, and pop-up goes away. Click on one of these again, and I see my pop-up. Okay, cool, but I want the pop-up to do more than just say hello there. I want it to tell me what point of interest I clicked on. I want it to link to the detail page for the point of interest. How do we do that? Well, up here, when we click on a marker and we call set show pop-up, instead of setting it to true, let's pass in the POI. So pass in the point of interest object that we're iterating over. So now instead of true or false, Show pop-up is going to be an object that has our point of interest information. So our latitude will be show pop-up dot location dot latitude. Longitude will be show pop-up dot location dot longitude. And we can start to show the details now in the div, in the content for the pop-up. So what should this be? How about, not string, so in bold, show pop-up dot name, and then I think we have the type as well. Let's put that in parentheses. Pop-up dot type, and then we can link to it. Target, let's open a new tab when we click on, so this will be a link to the detailed page, which is going to be, what is this going to be? This is just going to be slash show pop-up dot node OSM ID. So we're using the ID of the point of interest. And call that details. And what did I do wrong there? href. Do closing curly brace. There we go. Okay, so we don't need this closing curly brace. Okay, so that'll link to the detail page for the point of interest. If we rebuild that, and let's refresh over here. Cool, so now when I click on one of these, it says Bank Rock Bay, water. I have a link to the details page, and I link to the detail page for that point of interest. Tennis court. What else do we have? Bicycle parking. Here's the reservoir. Cool. What else? Oh, we said we could add a photo. So let's see, do we pull that in? We don't pull in the photos. So let's add that to our GraphQL query for rendering this. So photos. Let's just grab the first photo. So now we'll have photos in this POI object, so we can render an image as well. So the image, let's set this to be kind of small. And the source is going to be show pop-up photos. And that's an array, so we grab the first photo URL. And let's see if that worked. Here's a point of interest. Yeah, cool. So now we've got, if we have them, we don't have these for all of our points of interest, but if we find a photo from the Mapillary API, we'll now show it in the preview. Cool. And we have a link to the detail page. Great. So I think that is what we wanted for the index page. So we're showing on the index page markers where all of these points of interest are. We still have a list, so we can get to our detailed page that way. But we can at least see the map view now where these things are. Okay, so that is the first part where we said we wanted to show a map. The second place we want to map is on the detail page. We want to show a marker where the point of interest is. We want to have a drop down then that's going to show all of the other points of interest and then show you a route from one point of interest to the other. So let's first look at our map and see what components we can use to do this. If we look at the source component, and let's grab our Mapbox key again. And plug that in here. Here, we're using a source component to render GeoJSON. This is a polygon. We don't really want a polygon. Here's a GeoJSON line string. That seems like more like what we want. Yeah, here we go. So something like this. So imagine we're showing the route from here to here. We know from 2 times ago, we can get something like this calling our GraphQL API. So specifically the Neo4j GraphQL API that is using those pathfinding functions, specifically a star, to find the route from one point of interest to the other. So that's what we want to render on the map. So we're going to use this source component. So we take a look at that. How does this work? Well, child components for the map, we have a source that is a GeoJSON of type GeoJSON, and it takes a data prop. So the data prop is the GeoJSON, so that is a feature, line string, and then coordinates. Okay, I think we can fetch that from our GraphQL API. And then we need to create a layer, and the layer specifies the type and the styling, how that is going to render the source, which is GeoJSON, onto the map. Okay, that seems like what we want to do. So that sounds good. What we want to do now is go to our blog post template page. So this is the template that is used for each rendering each of these detail pages. So the first thing we want to do is import our map in here. So let's do that. So looking at the docs again, we need useState hook. And our map and source and layer components and our CSS. And then in our component, we need viewport. And here we're setting our latitude. Let's use the default that we have here. Initially, that's fine. Well, actually, since we're going to do routing, why don't we use the same latitude and longitude that we used for setting setting the view to be centered on Central Park. So we'll just copy that from last time, and that way the map will be centered in the same spot as our main map. That should look good. Okay, and then we need to render our map somewhere. If we look at the detail page, maybe we should render the map right below the image. It seems like a good spot. So we'll put our map here. The style is, let's just copy this from here so we don't have to type this again. I think most of this is going to be the same. And let's format that. There we go. Okay, so style, map style, our access token, latitude and longitude and zoom. And we get some warnings and an error, specifically, oh, we spelled mapgl wrong. Mapgl, the L is capitalized. Okay, cool. Here's our map, great. Okay, cool. So now what we want is a marker for wherever we are, wherever our current point of interest is. So let's add that. Did we import a marker? Source layer and marker. Marker. There we go. Okay, so we've got our marker, and longitude is going to be what? Well, remember we have this post object, so if we look up here, post equals data.poi.pointOfInterest, the 0 index. What's going on here? Well, for each of these template pages, Gatsby runs a GraphQL query against the Gatsby GraphQL API, which is down here. And so this means that for each one of these pages, this is the information that we have. So we have all of these fields here in the selection set. So we have latitude and longitude, photos, and so on. So we have latitude and longitude, which is going to be post dot location dot longitude, and latitude is post dot location dot latitude. Okie doke. And I'm going to use my same SVG that I copied from another map example. So let's drop that in here. Okay, and so because we want to use this as kind of like a starting point. So here we can see our marker. I guess first of all, let's make that a little bit bigger. Let's get rid of this transform. I don't need that. And let's change the color to green. So green is our starting point. So here we are for the reservoir. This is our starting point. If we go back and select some other, so maybe, I don't know, down here, what's this one? The musical clock. If we go to the musical clock page, you can see, yep, we're down here, the musical clock. Cool. So a couple questions in the chat. Can we face n+1 problems using Neo4j? Do you mean the n+1 problem with GraphQL? So in the context of GraphQL, when we build the backend for a GraphQL API, so let's look at this selection set, for example. So because GraphQL has these very nested queries, oftentimes we'll make a query for, in this case, say the point of interest, and we'll go to the database to find the point of interest by, in this case, node OSM ID. And then we say, oh, well, now we need some information about the location of that, the tags for it, and we might make multiple round trips to the database to fetch that information. So in GraphQL, this is the n+1 query problem. And because we don't want to do that, we want to only make one round trip to our data layer because that's going to be a lot faster. Making multiple round trips when resolving a GraphQL request introduces a lot of latency. So we don't want that. So the question is, when we use GraphQL with Neo4j, do we have this n+1 query problem? And the answer is not using the Neo4j GraphQL JS library that we're using. So if we take a look at the code for our Neo4j GraphQL API, you can see we're using this Neo4j GraphQL JS library where we just pass in our type definitions to make augmented schema, and that generates an executable schema object. The only resolver we wrote was the one that's calling out to the Mapillary API. So what that library is doing is for any arbitrary GraphQL request, so even this one, it's generating a single database query. So if we look here, we don't have our logging enabled to show the generated queries. But what's going on there is we're generating a single database query from any arbitrary GraphQL request. So that we're only sending one database query and then letting Neo4j optimize the execution plan for that query. And because graph databases like Neo4j are optimized for these traversals, which is like this nesting in a GraphQL selection set, it ends up being really fast. There's some more information in the docs, I think, in this schema design. Yeah, so this page talks about it a little bit. This n+1 query problem, and then so if we look at here, single database query, one of the goals. And then I also wrote a blog post called, let's see if we can find it, 5 problems with GraphQL and how Neo4j solves them, something like that. 5 common GraphQL problems and how Neo4j GraphQL aims to solve them. Yeah, and so in this blog post talks specifically about this n+1 query problem, how we address that with Neo4j GraphQL. So answer your question, no. We do not have the n+1 query problem when we're using GraphQL with Neo4j. If we're using one of the GraphQL integrations for Neo4j, because we're generating a single database query which then gets optimized by the database. So great question. Will the legendary Dosa Man be on a marker? I don't know. Who's the Dosa Man? Let's. Oh, is this like a food truck? Is he in Central Park? I'm not sure if we have that from OpenStreetMap. That is a good question. If he's listed in OpenStreetMap, then we should have him in here somewhere. That's a good point. We don't have a great way of filtering by categories. You can search for DOSA. I don't have any DOSA. One thing we'll want to think about is we don't have a great way to search by category either. So I'm just kind of showing you a list, and we kind of have to click around to see what we want. But really, we should have some way to filter by category of thing that we're looking for. So that might be another feature that we want to think about building. But yeah, good point. That's fun. And then another question, how could we avoid a path inside water? Yeah, that is a good question. So if we're going from here, the Bertol statue, to here, Central Park Police Precinct, fastest way is just to cut across the water, but obviously that's not reasonable. And what we'll see when we add our routes here is that that's taken care of us because of the OpenStreetMap data that we've imported into Neo4j. So we have all of these footpaths, and there's a couple streets in Central Park as well, but we have all of those in the database, and our routing algorithm will take that into account. So what we're doing with our routing algorithms, which we can talk more about in a sec here, they're looking at all of these paths that we've imported into the database to try to find the shortest path from one point to another. And hopefully none of our paths cross over water, so that shouldn't be a problem. Okie doke. So let's go to our detail page. We've got our marker. It's in the right spot. That's where the reservoir is. And what we want to do now is present the options for routing. So we want, we will keep the UI element simple here, and we'll just have a drop down with all of the possible points of interest that we can go to, and let a user select one, and then we'll show them the route to get there. Okay, so let's add that UI element. So maybe we'll put that right before our map. We'll say route to, and then a select element. And we need some on change handler for that. Let's call that on route change, or how about on route selected. We'll define that in a second. Okay, and so we're going to have like options in here that have the name of the route of the other points of interest, but where are we going to get those? Well, if we take a look at our GraphQL query, so this GraphQL query runs when this page is being built, and currently it looks up point of interest by slug or by ID. So it takes this part of the URL path. This is the ID, the node OSM ID, and looks that up using GraphQL to get the details of the page to render. So what we can do is modify this query to return all of the points of interest. So let's alias this to all POIs. It's going to be selecting the POI field and then the point of interest field. And previously we passed in the node OSM ID down here to only give us the one that we're interested in, but we want to know what are all of the possible points of interest that you might be able to route to, and we'll need the name and the node OSM ID. Okay, so now that means that on our data object back up here, or right here, so this data object, so Gatsby runs this GraphQL query for us and then passes the result of that GraphQL query at build time into this data object. So that means when we add this select element, we can map over data.allPOIs.point of interest. Map over those, the point of interest and the index. And we can render an option element where the key is the index. Remember, with React, we always want to specify a unique key whenever we generate an array of elements. The value, this is going to be the node OSM ID of the point of interest we've selected, the one we want to route to, and we'll display the name. Okay, so let's try that. So that's going to rebuild all of our pages now because we've changed this GraphQL query that we're running. While we're waiting for that, let's define a function. So we said on route selected is going to be the change handler for this. So let's define that up here. So on route selected, that's going to be passed an event. And what do we want to do here? Well, this means that, okay, the user has selected a route or selected a point of interest, and we now want to go back to our GraphQL API and, oh yeah, it's complaining that we haven't defined on route selected, but we did just define it. There we go. Okay, so we were saying, what do we want to do in the on-change handler for on route selected? Well, what we want to do is figure out what the route is. And to do that, we're going to query the Neo4j GraphQL API. So if you remember, we spent some time previously exposing the A* pathfinding algorithm through GraphQL. So we want to find the optimal route from the current point of interest to whichever one was selected. How are we going to do that? Well, to do this, we're going to need to run a GraphQL query and then transform the results into that GeoJSON format that we saw in the docs here. So transform the results of that route query into this GeoJSON format and add a source component to our map to render that. So cool. Okay. Before we do that, let's make sure. Here's our dropdown now. So for each one of these, let's go select a different page. Let's select, that's a no name monument. There's the azalea pond. Yeah, cool. So we've got a whole bunch of points of interest that we can route to. Okay, cool. Before we get into that, question in the chat regarding GraphQL documentation. Is it possible to customize the GraphQL docs and schema? The generated query hyperlink points to GrandStack in the docs. I want that to be pointing to the documentation link I create. Yeah, so when you're defining your GraphQL type definitions, so like here, for the types and the fields, if you add doc strings to this, then that will show up in Playground, for example. Will show up in here. I think we also now generate some documentation strings that point to the documentation on GrandStack for things like if you're using like the native datetime type or some of the generated query fields and so on. I think I'm using an older version that doesn't have that feature. But yeah, it should, if you add your own, it should override whatever the default is, Uday. So if you're not seeing that behavior and you're not able to override the default in your type defs, then that's a bug. I guess though, for some of the generated things are not exposed. Yeah, oh yeah, and so like for links and stuff, you can use Markdown in here, I think, is what we do. But there are some generated things I think that aren't really exposed. Like how would you override the documentation for some of the native database types that are added by the GraphQL integration to the schema? I'm not sure if there's a way to override those. I guess you could declare those types in the schema explicitly. But yeah, if you find that you're not able to override those, that's a bug and open an issue, and we'll take a look at that. Okie doke. So we want to now run a GraphQL query when the user has made a selection in this dropdown. So that's our next step, right? So blog post template, right? So filling out here basically, right? So they've selected a point of interest. It's in this event object passed into this onRoute selected function. So how do I run a GraphQL query now? Well, to do that, we will use Apollo client. So Apollo client, these are the docs, queries, under fetching. We're using React, so we can use the use query hook. In this case, we actually don't want the use query hook. And the reason is that the use query hook will execute a GraphQL query immediately when the component is mounted. And that's not quite what we want here. We only want to run this query to find the route when a user has selected something from the dropdown. So in that case, we want here executing queries manually. So instead of use query, we're going to use the use lazy query hook. So this is kind of like, this is more similar to, I guess, the mutation hook API, where we get a function then that we can call. So here we define get dog photo query, pass that to the use lazy query hook, which then returns this tuple. And the first element of that tuple is get dog, which is a function that we can call to execute that GraphQL query and pass in variables and stuff. In their example, it's happening in the event handler for a button, which is basically what we're doing, except we're doing it in the event handler for our select element. Okay, cool. So we know we want to use Apollo client. We know we want to use the use lazy query. How do we use Apollo client with Gatsby? So Gatsby does some GraphQL things already. I mean, we've seen how, for example, in each of these page templates, Gatsby runs a GraphQL query for us at build time. We saw how that happens in the this Gatsby node file previously, how we use that to find all of the pages to render, again, at build time. But how do we run GraphQL queries not as like static queries, but during outside of build time after we've already built our application? Well, it turns out there is a plugin for that called, I think is it called Gatsby Apollo plugin, I think? Yes, Gatsby plugin Apollo. And so what this does is we add this plugin to the Gatsby config, point it at a GraphQL endpoint. We can also pass in credentials if we need those. In our case, we don't. And then this will make sure that the Apollo client instance is instantiated and injected into the React component hierarchy so that we can then use those Apollo client hooks. So let's install this. So npm install Gatsby plugin Apollo and Apollo client. And then in Gatsby config for our plugins, we need a new plugin. So resolve Gatsby plugin Apollo options. URI is going to be HTTP localhost 3003. We'll just hard code that for now. That's fine. And then Gatsby develop to restart our Gatsby app. Okay, cool. So now we will have a Apollo client instance injected into the component hierarchy, and we can make use of this use lazy query Apollo client hook. Cool. So while that is building, let's take a look at the query that we want to run. To do our routing. So running on localhost 3003, this is our Neo4j GraphQL API. Let's jump back and take a look at the code for that. So here's the type defs for that GraphQL API. That's maybe a bit too big, I guess. We have steps, this is basically just a point type that has latitude and longitude. This is meant to represent each step in a path. We have tags, so these are the OpenStreetMap tags, and then we have points of interest. And on each point of interest, we have a route to POI field that takes a POI, so an ID of some point of interest, and it returns an array of steps, so a bunch of latitude and longitudes. Okay, so that means that we've resolved some point of interest, we want to route to another one. And then the logic for that, we're using a Cypher schema directive. So Cypher schema directive, this is my favorite, where'd we go? This one. This is my favorite bit of functionality in the Neo4j GraphQL integrations that allows us to define custom logic in Cypher and attach that to a GraphQL field. And in this case, we are using the Graph Data Science library, using the A* algorithm to find the shortest path between these points of interest. So let's run this. So let's get the first 10 points of interest, turn the name and node OSMID, and then we want to route to POI. So let's find the route from the reservoir to the pond. And it's going to give us latitude, longitude. We'll change this from the first 10 points of interest to just the first one. So we're saying, find the first point of interest, which in this case happens to be the reservoir. Give me the name and the node OSMID of that point of interest, and now find the route to this other point of interest. And I get a whole bunch of longitude and latitude pairs. Okay, cool. So this is the query that we want to run when a user selects that dropdown. So we want to run this query, but basically replacing the POI and the node OSMID up here with variables that we will fetch from based on whatever the user has selected and whatever page that they're rendering. Okie doke, it looks like we got an error here for photos. Right. Something timed out. Did our, oh, I wonder if, let's do a Gatsby clean and a Gatsby develop again. I wonder if there was some issue with a timeout with the Mapillary API, perhaps. I'll give that a rebuild. Maybe we hit our rate limit on the Mapillary API. Okay, so while that's building, let's start working on our GraphQL stuff. So we now should be able to import, use lazy query. So this is the Apollo client hook we want to use for manually executing a GraphQL query. And we want the GQL template tag for parsing GraphQL queries from Apollo client. And then let's also define our GraphQL query. We'll wrap that in the GQL template tag. That's going to parse it. So basically, what we want is this query here, but we are going to add some GraphQL variables to that. So this is going to be, let's call this get route, and this is the syntax we use to define GraphQL variables. So we're going to have a from variable that's going to be a point of interest ID, and a to, it's also going to be a required ID type. And then we're going to call the point of interest field, and we're going to look up the node OSM ID. That's going to be the from. So whatever detail page point of interest we're currently looking at, that's going to be the my headphones clicked off there. Yeah, it looks like they're still on. Okay. Holler if you can't hear me for any reason, but I think we're still good. Okay, so route to POI, that's the field that we want to select on the point of interest, passing now the to point of interest ID, and we want to get back a bunch of latitudes and longitudes. Okay, cool. So that's the query we want to run, and then we want to, down here, we'll say get route, and then also loading in data. So those are the, if we have a loading state when we run our query, we'll have a value in loading. Otherwise, we'll have the data in data. Get route query. Okay, so we're using the use lazy query because remember, we don't want this query to execute when we mount this component. We only want to execute the query when a user makes a selection from the dropdown and our on route selected change handler gets called. There's one problem here in that Gatsby passes in a prop called data, so we don't want this to be called data. Let's alias this to route data. Okay, so now that means that in our on route selected, so in the event handler for that dropdown, we can call get route. And the variables we're going to pass in, remember we need a from and a to. Well, the from, this is going to be the post object, so this object here, from the data object from this GraphQL query that Gatsby runs for us during the build process. And then the to, well, that we're going to grab from this event. So this is the change handler for that select dropdown. So it's going to be e.target, that's the element, the select element, e.target.value. And for now, let's just log that. So we'll log the route data. A couple of questions in the chat. Is there a limit on properties and relationships a node can have? And how can I take text from React and search any node in Neo4j with GraphQL? I assume I can create a custom query in GraphQL, but not sure how to do a free text search in Neo4j. Yeah, great questions. So your first one, is there a limit on properties and relationships a node can have? I mean, not a practical limit. There's the format of the file store in Neo4j, I think, imposes some limit of the number of properties, but it's something like, I don't know, tens or hundreds of thousands. I'm not even sure what it is. So you run into, I think, a data modeling problem before you hit the limit of the number of properties you can have. There's a separate property store. So all property values are written out in the property store once you get over a certain number of properties that just expands out onto disk. So basically whatever you can fit on disk is properties that you can store on a node. You typically, though, don't want to store large properties. So if you have like a image or something like that, you probably don't want to store like a blob, a binary large object. You can store byte arrays in Neo4j. But typically what you would do instead is like store that image in S3 or something like that, and then store a reference to it. So storing large properties is typically not a good idea, since Neo4j is optimized for traversing the graph, not loading large properties from the property store. That can, if you have very, very large properties, that can sometimes slow down traversals. In terms of the number of relationships a node can have, I mean, there is, some like physical limit. Well, let me back up. Relationship types. So the number of relationship types that you can define, there's some, I don't know, extremely large limits that, again, you'll probably hit a data modeling error before you actually hit it. And then in terms of the actual relationships that can be connected to any one node, or the number of relationships you can store in the graph, no, there isn't really a practical limit. It basically maps to, whatever you can fit on disk in terms of the size of your data set. Then your other question about taking text and searching with GraphQL. Yeah, so if we look at our point of interest nodes here, there's a filter object. So this filter object is generated for any type that we define in Neo4j GraphQL. And for string properties, it generates these starts with, contains, ends with filters. So if I want to search where the name contains statue, so show me all of the points of interest that contain statue. Oh, I only find one. Alice in Wonderland. What about, what would be another one? I don't know, tennis? Aren't there a bunch of tennis courts or something like that? Yeah, so that's one way to do it. I can search using these generated filters specific to any properties. If you have more custom needs, like let's say I want to do search across a bunch of different properties of a node. So maybe I want to search the name, the type, the description for some keyword, or I want to do fuzzy matching. Then you can use some of the full text search functionality in Neo4j, and you can expose that via a custom query using a cipher directive. There's an example in the guides. Where is this? It's in the docs for custom logic, I think. Custom top-level query fields? Yeah, so custom top-level query fields. So this example goes through how to use the full text index functionality and expose that to do fuzzy matching across a bunch of different fields, properties on the node. Let's say of type A and B with property called description. Yeah, exactly. Yeah, so that's exactly you'd create a full text index like this. Here it's just using the name property on the business node, but you can add this, you can create the index that will include multiple node labels or properties. And then a query to that index will give you nodes that match it, even if it's a business, or let's say we added reviews here, or whatever matches in the index. So yeah, it sounds like that's what you want. Cool, yeah, good questions. Okie doke, so let's test this out. Let's choose a point of interest. Doesn't matter what we pick. Sure, how about the Beethoven statue? Here it is on the map. And let's say we want to route to the Great Hill. Okay, nothing happened. I don't think we expected anything to happen. Let's open up the console. Did we get an error? Looks like we got a bad request. So let's, yeah, we did. Create HTTP link. Bad request. Because, yeah, no, that's right. Let's take a look in the network tab. So we got a 400 bad request. What is the variable from of required type ID was not provided. So if we look at the query that we ran here, it's kind of hard to read. We ran, yeah, our get route query, but then in our variables object that we passed, it had a to object, but it did not have a from object. Well, why is that? Well, our from defined here, so we said post.nodeOSMID. So here's our post object. That's the current point of interest. Let's look at the GraphQL query. Oh, we're not getting the node OSMID. So node OSMID is not included in the selection set for the point of interest on the detail page. So if we add node OSMID, then that should now be defined here when we pass that query here when we're building up the variables object to pass to the use lazy query. So because we changed the GraphQL API or the GraphQL query, Gatsby needs to rebuild all our pages. So while we're waiting for that to build, let's think about, we know we're going to have, let's look at previous queries. This the route? Yeah, that's the route. So if we look at our route query, we're going to have data of this format. So a bunch of these latitude, longitude objects. And to render that on the map like this, we need to transform that into GeoJSON. So we want to think of how we're going to do that. I guess what we'll want to do is, let's define a variable. This is going to change, so we'll use a let, and then we'll say if we have route data. So route data, this is only defined, so now we're using this use lazy query Apollo client hook. So route data here, this is only going to be defined after we've actually successfully fetched some data. So we'll say if we have route data, well then route GeoJSON is going to be some object, and the format that we want is just following this example. This is a valid GeoJSON, which is a specification for defining geometries using JSON. So feature, and the geometry is of type line string and coordinates. So here, type line string, and then coordinates, that's going to be the route that we want to render. Well, this coordinates is a list of lists or an array of arrays, where the first one, the first element in the nested array is longitude and the second is latitude. But we have something that looks like this. So this is going to be route data dot, so following format, dot point of interest. And this is a list field, so select the first one here, dot route to POI, right? So here, this, just following this selection set structure, route to POI, and we're gonna, and this is now our list of latitude, longitude objects, and we want to convert each one of these objects. So latitude, longitude as an object, we want to convert that to this, to a array, where longitude is the first element, latitude is the second. So we'll map over that and return an array, s dot longitude, s dot latitude, so longitude. And then let's log that. Okay, so now we go over to the Beethoven statue, and where is it? Here it is. Got our marker, and we want to route to the zoo school. Well, nothing showed up on the map, but if you look in the console, here we're logging something from line 57. That's here. Cool. So we've logged this GeoJSON object. So type, feature, geometry, type, line string, coordinates, and then we have a bunch of coordinates. Cool. So that looks like a route. That is good. Now we want to add that to the map. Let's go back to our documentation, looking at how we show this line string on the map. we've got our GeoJSON object now, so that's good. So we want to create a source and a layer. So let's look, where's our map? Here's our map. We defined our marker, so that's good. After the marker, so first let's check for route GeoJSON. So only in the case that we actually have called our Neo4j GraphQL API, gotten the routes, we've converted to GeoJSON. So only in the case where we have this GeoJSON object do we want to render the source and the layer component. So let's check that that is not null first. And then let's render, we can wrap this in a div, I guess. So now we'll render a source here, like this over here, source component. Let's call this route. It's going to be of type GeoJSON. The other types, I think you can pull in remote sources as well. So I could like hook this up to like a Geo server or some Mapbox service or something like that to pull in remote sources. But it's going to be GeoJSON. The data is going to be this route GeoJSON object. And then we need a layer. And the layer ID is route. Let's format this so it's a little more readable. There we go. Okay, so on our layer, what else do we have? We have a type, a source, a layout. So let's add those things. So the type will be line. The source is going to be route. So that's the name that we gave this source here that is bound to our GeoJSON object. Then the layout. So this is some styling here. So I'm just copying what we have from our example in the React Map GL docs. So a line cap is round. And what else? Paint. So how do we want to style that? Line color. Let's do blue so it stands out a bit. And line width, do 8. That's what this example uses. That's pretty visible. That should be fine. Okay, so that should render our route. Let's also add a marker, because we had like a starting point green marker. So let's also now render a marker. I'm just going to copy this one. We could probably move some of this out into separate React components, so we don't have so much logic in this one. Something to think about. Okay, so now we have a marker instead of green. Let's make this one red. And the latitude and longitude, instead of where the starting point is, which is the point of interest that we're showing for the detail page, we want the last element of this GeoJSON coordinates array. So the last latitude and longitude point. How do we get that? Well, that's going to be route GeoJSON dot geometry dot coordinates, and then I need to index into that. I need to know the size of that array, I guess. So this is a little awkward. We could write a function to extract this, but this will work. Route.json.geometry dot coordinates dot length -1 should give us the last, since we're doing zero-based indexing. And then I want the first element to give me the longitude, and then exactly that. Exactly that. We'll copy paste that, but the second element will give me the latitude. Okay, I think, let's format that, it's a bit more readable. I think that should do it. Let's see what happens. So here we are at, zoom out a bit, there we go. So here we are at the Beethoven statue, and let's say we want to go to the Three Dancing Maidens statue. Cool, there we go. So here's the route that we get. If we zoom in, we can see the path that we're following. So there's this footpath here. You'll notice that this isn't exactly following the geometry of these paths. And the reason for that is the routing graph that we've built on top of the OpenStreetMap layer only includes the intersections. So we don't need to make a decision at every single, they're called OSM way nodes in the data model. So the OSM node is every single like observable point that someone has mapped in OpenStreetMap. So for the routing graph, we're only routing between intersections. So you'll notice some things that don't quite follow the outline of the path. That's because we're just basically drawing a straight line from one intersection to another. So this footpath intersects here, and then it also intersects this other footpath here. So we just draw a straight line between those intersections. But I think this is good enough to give us an idea of what path we're supposed to take. So this is the A star shortest path going along these footpaths. And then we get up on, looks like we get up on Fifth Avenue to go on a straight shot past the museum, and then this is neat. It knows exactly how to get through these footpaths here that go in a circular area around this fountain. Cool. That looks fun. Let's select another one. How about the Duke Ellington Memorial? Oh, that one was very close to the one we just did. That's very similar. About something down here. What's down there maybe? The Worthless Boulder. I don't know where that is. Oh, again, that's almost way up there as well. So you can see here's a path that's cutting across the water, but again, this is more just because of the intersections only that we're plotting. We're actually taking this footpath around. Cool. Let's try this for some other points of interest. Let's see. How about, here's the Dancing Crane Cafe. So from the Dancing Crane Cafe to the Harn Shed. Let's see, let's make sure we go around the water for that one. Where was that? This one, Dancing Crane Cafe, which is here. And where did we say we wanted to go? To the Harn Shed? I guess these aren't in any particular order. Here's the Harn Shed. Yeah, and so that routes us along this path, and then along this path along the water. and then coming in on this footpath. And again, this is the actual path we're taking, but we only see the intersections. Uday says, let's route to the Loeb boathouse. Yeah, where is that? Is that on the reservoir? I don't actually know. Let's see, where's the boathouse? The blockhouse. Yeah, we should put these in alphabetical order or something like that. Here's the azalea pond. Actually, we can. Let's put these in alphabetical order. How would we do that? Well, to do that, point of interest. Well, here, let's do it in here so we can see what it actually looks like. We would say order by name descending. Or actually, I guess what we want is ascending. That probably makes more sense for alphabetical. So we add an order by name ascending order. So this, all POIs, this is what we're using to fetch these point of interest. So we order those in ascending, which should make it easier to find things. Code Lumberjack says, hey, I enjoyed your talk at Nodes. Cool. Thanks. Thanks for coming to Nodes and watching our talk. Glad you enjoyed it. I think we looked at this earlier, but I didn't specifically call out my talk. So since you brought it up, we can do some shameless self-promotion here. So Nodes was our online conference. That was a couple days ago. If you go to the site now, you'll see that the Content Hub is linked, and these are all of the recordings and all of the slides from the talks. And I gave a talk called Low Code GraphQL APIs with Neo4j. I'll drop the link to this here in the chat for anyone who missed that. There's a lot of things that we covered in here, kind of the high-level goals for the GraphQL integrations, and then we take a look at GraphQL Architect specifically. So we haven't used GraphQL Architect. It is a graph app for Neo4j Desktop. We've played around with it a bit on the stream, but it makes it easier to build GraphQL APIs backed by Neo4j just within Neo4j Desktop without writing any code. So if you want to be able to, say with one click, get a GraphQL API on top of your Neo4j database, this is the tool for that. We'll drop some links in the chat for resources that point to that. And then the other thing I mentioned in the Nodes talk is that we're going to be doing full stack GraphQL book club next week on the chat. So if you want to participate in that, download this free ebook. This is the first few chapters. There's 3 chapters. It skips chapter 2, but that's fine. We'll do that in the book club. And we'll start next Thursday on the stream doing the exercises from that. Anyway, sorry for the distraction there. You got me thinking when you mentioned nodes. Okay, so back to now our app. So now things are in alphabetical order, so we can more easily find the Loeb boathouse. So here's the route from where we Dancing Crane Cafe to the boathouse. Which I think this is where you see the iconic pictures of couples romantically in rowboats in Central Park. Is that where you rent them? Maybe? I don't know. Okay, cool. So that I think is everything we wanted to add today. Anyway, bit of a long stream, so thanks for the folks that stuck in there and got everything completed. Just a recap of what we did. We added this map. So on the index page of our Gatsby app, we added this map with a marker for every point of interest that we have in the list below, with a detailed view so I can see for each of these what it is, what type of point of interest it is, a link to the detail page, and then if we have an image from Mapillary, we have that here. And then we added this other map, which shows us initially a marker for wherever that point of interest is. Then we added Apollo client to our Gatsby app so that now, instead of running GraphQL queries against the Neo4j GraphQL API at build time, we're running them live when a user selects a point of interest, and we're using the A-star graph algorithm to find the optimal route from one point of interest to another, and then rendering that on the map. And to do that, we used Mapbox GLGS, and specifically the Urbica React Mapbox wrapper for Mapbox GL. Cool. So I think we'll call it good there. Thanks again, everyone, for joining. I hope that was fun. And like I said, next week on the stream, we will pick up with chapter 1 of the Full Stack GraphQL Book Club. So if we look at what that is, grandstack.io/book. Here's the table of contents. So chapter 1, what's the grand stack? So chapter 1 is more of an overview chapter, but this should still be interesting. There's still some exercises in there that we'll do on the live stream next week. But this gives an overview of what grand stack is, how the pieces fit together, why should we use these components, why should we use them together, that sort of thing. So again, here's the URL to download the book. If you want to participate in book club, I guess you don't need to do any homework for this. If you don't need to, we'll do the exercises together. But anyway, I hope you can join next week as well. I will push up the code for today to the GitHub repo, which is here. And you can also find the recording. I'll link it here, but also be on the Neo4j YouTube channel. Cool. So with that, we'll call it a day. Thanks for joining, and we'll see you next time. Cheers.